In the last lecture, we have discussed the vector, why we study vectors, and what are different types of vectors. And the most important topic which we have discussed was the unit vector. And now I will discuss today about the zero vector. What is a zero vector and why the need of zero vector was there, and what are the properties of zero vector. So I will discuss today all about the zero vector. So first of all, define zero vector. What is a zero vector? As its name suggests to you people, it is a vector which is having zero magnitude. And what about the direction? It is having changing direction, because as the vector with which it is multiplied or to which it is added, its direction changes accordingly. So we can write zero vector. It is a vector having zero magnitude and arbitrary direction. Why its requirement is there? Why zero vector is needed? How it can be written? It is written as 0 and vector sign on itself. It is denoted by this. Why the zero vector is needed? This situation is if vector A is equal to vector B, and now what is vector A minus vector B? What is this? When both are equal and we subtract these two values, what we get? We get 0. Hence, to write here 0, we needed the zero vector. Clear one point? If A is equal to B, now what is the difference of these two values? There should be 0. So we cannot write it as it is. To write here 0, the need of zero vector is there, and it is the vector having null magnitude. Null means the value 0. Here this is 0. And the second situation is there when mu is equal to minus of lambda, where mu is non-zero, lambda is non-zero, and if mu plus lambda is multiplied by a vector, and if these are non-zero values, and if answer is equal to 0, this term is already 0 from here, and how it can be equal to zero vector? This A must be a 0. So to explain this type of concept, a zero vector is required. Now what are the properties of zero vector? First property, when zero vector is added to a vector, it gives vector itself. This is the first property. How? If zero vector is added to vector A, then in result we are having vector A, and the direction is same as that of vector A. So note it down please. Second property, what was first? First property, when a vector is added to 0 vector, then it gives the vector itself. Second property, when any vector is multiplied by 0 vector, then it will give 0 vector. It will give 0 vector. You know, if something is multiplied by 0, then it will give 0. This will give you 0 vector. And then third property is when lambda A is equal to mu B if lambda and mu are non-zero numbers, then this relation is valid. कब valid होगा? Valid only when this is non-zero, this is not equal to 0, this is not equal to 0, and this whole term and this term are equal. When they are equal, valid only when vector A is equal to vector B is equal to 0 vector. So these are the properties of 0 vector. First, when we'll add 0 to a vector, it gives the vector itself. Second property, when we multiply a vector with 0, then it gives 0 vector. Third, when a non-zero number is multiplied by vector A, another non-zero by multiplied vector B, and they are equal. This relation is valid only when vector A and vector B are equal to 0. So note it. Now next topic is the composition of vector. What do you mean by the composition of vector? Composition of vector means adding the vectors, and while adding the vector, what they constitute. So when two or more vectors are added, then they gives the result their combined effect. So the question is there, what is the resultant of vectors? The resultant of vector is the combined effect produced by a single vector as is produced by the total effect of the individual vector. So the composition of vector we study by the laws. First, the triangle law of vector addition, then the parallelogram law of vector addition, and polygon law of vector addition. So write it down, the composition of vectors. Composition of vectors. First of all, we will define the definition of composition of vectors. Hence you can write the resultant of two or more vectors produces the same effect represented by a single vector as is produced by all the vectors as is produced by collectively by individual vector. vector. This is known as composition of vectors. Composition of vectors. How we can study the composition of vector? We can study these by triangle law of vector addition. Triangle law of vector addition. Secondly, parallelogram law of vector addition, and third one is polygon law of vector addition. How we can write it? Suppose this vector is represented by A. In the same order, the next vector is represented by vector B. Then starting from A, in opposite order, this is given by their resultant. So the result which is produced by collectively by vector A and vector B, this collective result is equal to the vector R. So we can write vector R, the resultant which is produced by the single vector, is equal to the sum of these two vectors which are having their individual effects. So this is the triangle law of vector addition. Okay, we talk about the parallelogram law. For the parallelogram law, the one vector is like this and second vector is like this. These two vectors are not in same order. If these two vectors are not in same order, but they are starting from the same point, so we draw the parallel line for this is of same magnitude and the parallel line of like this for the same magnitude, and we draw the diagonal. So suppose this was vector A, this was vector B, and this is the resultant. This is B. Again, we use the same method, but in this case, this diagonal will give us the resultant. So we can write R is equal to vector A plus vector B. Now what about the polygon law? Polygon law means there are many sides. This is vector A, vector B, this is vector C, this is vector D, and now this closing side from the starting point to the end point is the resultant vector. This is vector A, vector B. As they are producing the effect individually, and this resultant R is giving the combined effect of these four values. How we can calculate? First of all, we draw the diagonal. The effect of A and B can be written here, and then again we mark here. This effect was there. Suppose it is P. Then effect of P and C can be written here. This is Q, and then effect of Q and D will be R. So we can write it as vector R is equal to vector A plus vector B plus vector C plus vector D. This is the polygon law. How we can define this? Polygon law. If all the sides of the polygon are taken in the same order, then their result is given by the closing side of the polygon starting from the same point. This is the polygon law of vector addition. How you will write the exact definition? I will tell one definition to you people, then you will make both definition of parallelogram and polygon law. I will define only one, and you have to write in the similar manner. Here you will write, if vector A, B, C and D are representing the sides of polygon taken in same order, then from the starting point their resultant is given by the closing side in the opposite order. Same here, if two sides of a parallelogram, two adjacent sides of a parallelogram are showing you vector A and vector B, then their resultant is given by the diagonal of the parallelogram starting from the same point. Okay. Then triangle law of vector addition. First note it down. Then I am going to write the definition of triangle law of vector addition. Now triangle law of vector addition. Today I will define the triangle law of vector addition, and proof we will do in the next lecture. Similarly, you will have the definition and the expression for parallelogram law and polygon law. So how you will write it is, this is the triangle first side. This is represented by vector. This length is representing the magnitude, and this arrow is representing you the direction. So this is representing one side of the triangle in magnitude and in direction, and the second side in magnitude and in direction is represented by vector B. Then third side, the closing side, starting from the same initial point, suppose O, P and Q. The थर्ड साइड, द क्लोजिंग साइड डायरेक्शन आपको शो करनी है. अगर आपने एरो नहीं दिखाया, दैट विल बी कंसीडर्ड एज ए रॉन्ग वैल्यू. सो द डायरेक्शन इज मस्ट टू शो is representing the resultant. How you will define it? If two sides of a triangle are representing the vectors in magnitude and direction, then in magnitude and direction taken in same order. Same order means when the first vector is ending, having its head, you can say first vector is ending, then second vector will start from there. Taken in same order, then their resultant is represented by the closing side, or you can say by the third side, closing side of the triangle taken in is represented by the closing side of the triangle in magnitude and direction, in magnitude and direction taken in opposite order. And you can write R is equal to vector A plus vector B. Its proof I will discuss in the next class. The definition of parallelogram law and polygon law you will write in your notebooks. Note it down. This is all about the composition of vectors. In the next class we will derive the triangle law of vector addition.